So for instance here, say you were asked to solve this following triangle. So you're given triangle ABC here. You know angle A is 55 degrees. You know that side AB or side C, whichever way you want to name it, is 6, and side A or BC is 8. So what we're looking for here is we want to find the measure of side B, we want to find the measure of angle B, and we want to find the measure of angle C. Now, is that the order in which I need to find those things? Not necessarily, and I'm going to tell you quite honestly, chances are I'm not going to be able to find either side B or angle B first, because usually if I'm looking for a side measurement in a triangle where I'm looking to solve, if it's not a right triangle that is, I'm going to probably need to know the opposite angle or or vice versa. If I'm looking for a particular angle, I'm going to usually need to know its opposite side's length. In this case here, if I don't know side B or angle B, I don't have that. So for me to start off with something, and that's usually what you have to do a lot of times that's different from right triangles. Right triangles, I can usually find any of the given pieces of information that are still missing in any order. So I can say, well, I can find this side first, or I can find the measure of this angle first, or I can find the measurement of that. You can find any missing information in any order you want. In non-right triangles, typically one thing will be, most clear about what you need to find first, and then you can kind of proceed with finding additional things, and as you go through each, find each other thing, you may have more than one option of finding it. So here, I'm going to find the measurement of angle C first. As I said, no matter which rule I use, each of those rules, if I have an angle being named, I'm involving its opposite side, the side opposite of it. And if I don't know one of those two things, I'm not going to be able to solve that equation to find the other. So in this case here, I'm going to find the measure of angle C, and I can actually use the law of sines. The reason why I can use the law of sines safely is when I look at these angle measurements and side measurements. I know that angle A is 55 degrees. Its opposite side, it's measuring 8. Side C is 6 units in length, so it's smaller than 8, which means the angle opposite angle C, or the angle opposite of it, or angle C, should be smaller than 55 degrees. So I know I'm not going to have an obtuse angle if it's less than 55 degrees, and because of that, I can safely use the law of sines without having to worry about any possible miscalculations to be on the lookout for. So I use the law, I set it up, I have the sine of angle C over side C, which is 6, equaling the sine of 55 degrees, which is the sine of A, over side A, which is 8. So I solve the equation for C. So I multiply both sides by 6, I divide both sides by 8, and I do an arc sine of that to get it by 37.91 degrees. Now, I look to see what can I solve next. Well, again, I shouldn't use the law of sines or cosines to find angle B or side B, because for me to use the law of sines or cosines to do that, I would have to know one or the other. I don't know either yet. I can find angle B, though, by using the fact that the three angles of a triangle should add up to be 180. And that's another main difference between me dealing with situations where I'm solving right triangles and I'm solving triangles that I either don't know are right triangles yet, or are known to not be right triangles. Or, so since this was like given to be a right triangle, I have to assume it's not until I'm given any information that would show otherwise. But that difference is that with right triangles, I can also usually avoid using previous calculations to come up with other measurements in the triangle, whereas in non-right triangle situations, I'm usually going to have to use something I calculated beforehand in order to come up with other calculations. So here, now as I go through it, I'm going to try to minimize how much I use previously calculated values, but I'm not going to be able to avoid them altogether like I can with a right triangle. So I'm just going to take the easy way out and say, well, the three angles of a triangle should add up to be 180. I now know what two of them are. So the measurement of angle B is going to be 180 minus the sum of the 55 and 37.91 degree angles, which is 92.91. So the measurement of angle B is 87.09 degrees. And then, of course, now what I could do is use the law of sines again. Notice I'm doing it more of a reciprocal way. You know, in order to save a step or so, I usually put, you know, whatever variable I'm solving for, if I'm using the law of sines, on top. So since I'm solving for sides, I put the sides on top and the sine of the angles on bottom. So side B over the sine of 87.09 degrees should equal 8 over the sine of 55 degrees. And then when I multiply both sides by the sine of 87.09 degrees, and that is a number, so I'm going to get about 9.75. Now, in each one of these cases where I'm using the calculations, when I'm using the 37.91, when I'm using the 92.91, when I'm using the 87.09, I'm writing only a couple decimal places, but each one of these had more decimal places. I just rounded it to 2 decimal places. I'm using all the decimal places my calculator gave me, so keep that as a side note. So, you know, if you actually do 87.09 here, is it 9.75 exactly? Well, no. Would it round to 9.75? Maybe not, but it might be because I used all the decimal places when I did each one of these calculations, and not just the ones I wrote down. But I do get B is about 9.75. And one of the things you should definitely do, if nothing else, you know, I would check 2 things to make sure this is right. Make sure when I look at my triangle, is the biggest side opposite the biggest angle, or is the smallest side opposite the smallest angle? When I look at this triangle, yes, that's happening, so I'm good there. And I should also use the law of sines as a means of checking my work too. So if I do the sine of 87.09 divided by 9.75, and then do the sine of 37.91 over 6, and do the sine of 55 over 8, do I get approximately the same things? Again, they may not be exact because of rounding issues, but they shouldn't be that far off either. I mean, they should at least agree for the first 2 or 3 decimal places. If they're not doing so, then you're going to have an issue with that, and you need to make sure that you're going through your calculations, make sure everything is correct.